In this video, we're going to do an example of graphing a function using transformations. So let's start, say we start with the base graph of, we start with the function at y equals, let's do 2 times x plus 1 cubed minus 3. So this is a combination of several transformations. We notice that we've got a 2 multiplied on the outside of the cubing. We've got a minus 3 also on the outside of the cubing. And we've got this plus 1 on the inside of the cubing. So from that information, we know that the 2 and the negative 3, or the minus 3, I should say, are going to affect the y coordinates, the outputs. And the 1, the plus 1, is going to affect the x coordinates. So we'll start with our base graph. Our base graph here is y equals x cubed. Write that down here. So base graph will be y equals x cubed. Remember what y equals x cubed looks like. It goes through the origin. It goes through the points 1, 1 and minus 1, 1. Go through the point 2, 8. So 1, 2, 3, 4, 5, 6, 7, 8 up here. And matching one down here, 2, 3, 4, 5, 6, 7, 8. So it's down here. So we get to this cubic function like so. Okay. All right, so let's just go from left to right and see if we can figure these things out. So the first thing we notice is that we've got this 2 multiplied on the outside. So the first thing we have here is we know we're going to stretch vertically by a factor of 2. Now the easy way to do that, at least I think the easy way to do that, is we already have a scale here implied that we had a 1, a 2, a 3, and so on, a negative 1, a negative 2, a negative 3, and so on. The easiest way to do that, remember the stretching vertically by a factor of 2 is multiplying everything by a 2. So instead of having 1, 2, 3, we could just multiply our scale here by 2. So we have a 2, a 4, and a 6, negative 2, negative 4, negative 6, and so on down the line. And that automatically rescales our graph to where each y coordinate has been multiplied by 2. It's the easy way to do it. We don't have to retrace. We can just write it that way as a scale change. All right, what about the other ones? The next transformation we see is the plus 1. The way we can figure out the horizontal shift, at least the way I like to think about it, is we set that inside equal to 0 and solve for x. So the 1 tells us how many units we're going to shift, and the negative tells us what direction. So we're going to go 1 unit to the left. So we're going to shift 1 unit left. All right, so our scale for our x's was still 1, 2, 3, and so on, negative 1, negative 2, and so on. So all we need to do is just take this graph and shift it over 1 unit. So this point here will end up here. This point here will end up here. This one ends up here. That one's on the y-axis. This one's over here. And we get an exact copy of the graph, just 1 unit to the left. Finally, the last transformation we come to is at minus 3. That affects the y coordinates, and that one's going to be a shift down 3 units. So again, to draw that one really quickly, this one's going to go down 3 units, so it's going to end up down here. And notice that we're working off of each graph that we've changed before. So we're working off the blue graph to shift it down 3 units. This point's going to go down 3 units. This one's going to go down 3 units. This one's going to go down 3 units. This one goes down 3 units. And again, we get an exact copy of the graph. Just like so. Not a great graph. Let me try one more time here. I missed one of these. This one went down 3 units. Oh, I'm off in the... it should be right here. Sorry. That one also went down 3 units. That was what I was doing. I was missing the point here. This one goes like this and over and up, like so. And so that one will be our final graph of that transformation. So notice that the first thing we did, step 1, was changing the scale. Step 2 was shifting it left, and step 3 was shifting it down.